you're talking about camera, that time we already know why we use the aperture right here. This equipment help you to control the light goes through the lens and to see how the image on the image plane right here. To reduce the diameter of the aperture, the light rays passing through the lens on the outer edge are blocked, and thus reduce the size of COF on the image plane. So it can easily be seen that smaller aperture result reducing blurring. It means when you control aperture right here, you reduce the ray goes through the aperture and come to the image plane right here, and we can see the picture clearly, right? If the aperture is bigger, allows the light go through and the image is blurring. And one thing we know, when the light goes through the lens right here, is not the uniform surface, so they create a picture right here on the image plane. It's not exact, so people call it distortion. Okay, the distortion most relevant to practical radio distortion. The 2D position on the image plane after passing through the lens can be computed similar to the pinhole camera. So distortion more relevant practical distortion is caused by the focal length is not being uniform over its diameter. So they create the picture right here, look like parallel distortion or incursion distortion. So how we solve this problem? The magnification effect on the lens change depend on the distance between the camera center and the ray of the light passing through the lens. So if the magnification increase in the result, distortion effect is called the Gaussian distortion. It is decreased called the parallel distortion instead. The parallel distortion usually occurs when wide-angle lenses are used. No distortion, something like this. Okay, we always want the pictures of no distortion, but because we use the lens, it's not the uniform surface, so they create the distortion on the image. When extracting information from the camera image, many applications seek to draw a conclusion on the spatial location of objects of interest. For example, vehicles. So to get there, the distortion effect of the lens must be removed, right? So the relevance process called the calibration. So we use calibration to solving the distortion problem. So for each camera lens setup, calibration procedure must be performed, so distortion parameters can be individually computed. So, and the setup pictures well-known objects such as planar, trackball patterns from whose no geometry or lens are missed, sensor parameter can be robustly derived. The process of removing distortion from camera image is called rectification. Okay, calibration used to rectify most of image in the. So allow the trackball right here to use the calibration. Okay, calibration. Okay, here. So I don't want to go deeply the detail about this. We just briefly introduction about the camera right here. And here the coordinates of the image on the image plane. The point P right here in the space goes through the central camera and go to the image plane right here at the focal length right here. Okay, and we have the coordinates, the image right here. Okay. So one more thing is transformation process to move from metric to pixel coordinate. So to do that, we have the formula right here. Transfer from the space coordinate into the image the pixel coordinate. So one more thing I want to talk about right here in the principle, how the light goes through the image and create the picture on the image plane. When the image captured by camera, light passes through the lens and falls on the image sensor. The sensor consists of the light sensitive elements, so that register the amount of light that falls on them and converts into corresponding number of electrons. The more light, the more electrons are generated. Once the exposure time is complete, the generated electrons are converted into the wanted, which finally transform the discrete number by means of the ID converter. So right now we have to man the image technology CCD and CMOS. CCD is charge coupled device, or CMOS is complementary metal semiconductor. So both technologies convert electrons into wanted and are inherently colorblind, as they can now distinguish the different wavelength which generates the electron. To enable the color vision, the tiny filter element, the filter right now they have filter layer to guard the layer. Right now we have the green, red, and blue. Here we have the Bayer's pattern and filter layer. So mix the different combination RGB values can produce more color visible human eye. So when its discrete color value coupled with the 8 bits, total 16.7 million different color can be created with a RGB filter concept. So, and how about the CCD and CMOS? CCD sensor electron collects in each picture element are transferred from the chip through the single only few output nodes. The charge are often converted to wanted level buffers and send out analog signal. The signal then amplify and convert to discrete number using ID converter outside sensor. So CCD technology has several advantages compared to CMOS, such as the higher light sensitivity and less noise. So CMOS sensors are originally used for machine vision application, but image quality were poor due to their inferior light sensitivity. With modern CMOS sensor, while quality and light sensitivities have a significant increase. The CMOS technology has several advantages. Unlike CCD, CMOS chips incorporate amplifier and ID converters, which brings huge cost advantage. So here's something, the basis about the camera, the principal camera, and some definition of the camera, how the camera got the incoming light and they create the image on the image plane. That's basis one, and that's introduction. We don't need to go deep detail inside. So next we talk about the OpenCV library overview. Last video I have another video, so you have to install the OpenCV in the Visual Studio. Let's follow the step and you can do that. And in the OpenCV in C++, you have some library. Right here you can the core module, right, section of library contain all the basics, object type, and the operation. Okay, you always include OpenCV core SPP or high UE. This module contains user interface function that can be used to display image, okay, and text symbol input right here. Right now, image process right here, image processing module contains the basic transformation of image. Okay, image filtering, geometry transformation, filter detection tracking. You have to add this library. And the filter 2D module contains algorithm for detecting, describing, or matching key points between images. Right here, you have to include that. Okay. That's basic library for from OpenCV. Okay, I hope you can understand. And we go to the code right here.